Let's take a look at this homework problem. Let C be the curve y equals e to the 2.8x plus e to the negative 2.8x over 5.6. And we're looking at x values bounded between 0.1 and 2. They give us a nice graph of this curve here. And then if we rotate that about the x-axis, then we get this horn-looking shape, and we're asked to find the surface area of that object. Okay, and we're only looking at this outside surface area. It doesn't have a top or a bottom to it. Those would be circles, so that would be easy area to find and add in anyway if we needed to. This problem requires us to be a little bit clever with some of the algebra, so I'm going to go through that in detail. So here's our y equals equation. Our first step that we're asked to do in this problem, and this is a helpful little piece halfway through, is to find and simplify the square root of 1 plus y prime squared. So we're going to take this one step at a time. Here I have y. Before I differentiate, I'm going to do a little bit of simplification here. The denominator, 5.6, is a constant, so I think it's going to be easier to rewrite that as 1 over 5.6 times the rest of this stuff, e to the 2.8x plus e to the negative 2.8x. Now when we differentiate, that constant out front is just going to hang out. And I'm going to use the chain rule, so when I differentiate e to the 2.8x, I'm going to get the same thing times the derivative of the inside stuff. Okay, same thing with the second one. The negative 2.8 is going to come out, and the exponential stays the same. So this is y prime. Again, I'm going to do a little bit of simplification before I go on to the next step. I'm going to factor out my constant 2.8. Notice that 2.8 over 5.6 is 1/2. So this is going to be 1/2 times e to the 2.8x minus e to the negative 2.8x. Okay, this is y prime. Now let's look at y prime squared. So I'm going to take the expression that we had at the line above and square it. When I square 1/2, I get 1/4. And then I'm going to square this expression inside. Okay, in order to expand that out, I'm going to FOIL it. E to the 2.8x times itself is going to be e to the 5.6x, right? When we multiply like bases, we add the exponent. E to the 2.8x times e to the negative 2.8x. When I add the exponents, I will get e to the 0 minus another e to the 0. And then when I multiply this last term by itself, the double negative will give me a positive, e to the negative 5.6x. So we have 1/4 e to the 5.6x minus 2 plus e to the negative 5.6x. Okay, now let's look at 1 plus y prime squared. So what we're going to do is take this expression that we have above and add 1 to it. I'm going to write the 1 as 4/4 so that we have a common denominator and I can combine that in there. So I can bring this inside as a 4. 4 minus 2 gives me positive 2. Okay, here's where we have to be a little bit clever. When I looked at this line up here, e to the 2.8x minus e to the negative 2.8x, and I squared it, then I got this result, e to the 5.6x minus 2 plus e to the negative 5.6x. And now we have the exact same expression, except instead of a negative 2, we have a positive 2. And if when I FOIL this thing out, right, the negative times a negative gives me a positive. So this negative just means when I FOIL it out, the middle terms will be negative. And if I instead want the middle terms to be positive, I could just say, well, if this thing was positive, that would happen. And because everything else matches up exactly, this is going to factor into 1/4 times e to the 2.8x plus e to the negative 2.8x squared. So this is 1 plus y prime squared. Okay. So now if I want to look at the square root of 1 plus y prime squared, then I'm going to square root this expression that we came up with, 1/4 quantity e to the 2.8x plus e to the negative 2.8x squared. And when I square root 1/4, I get 1/2. And when I square root this expression squared, the square root and the squared will cancel. So we get 1/2 e to the 2.8x plus e to the negative 2.8x. So this answers the first part of our question on the homework. What is the square root of 1 plus y prime squared? Now we get on to the second part where we find the surface area. And our integral is from 0.1 to 2. Well, let's write it out generally. The integral from a to b of 2 pi y times the square root of 1 plus y prime squared dx. So let's write in our y and our square root 1 plus y prime squared. Our limits of integration are going to be from 0.1 to 2. The y is 1 over 5.6 times e to the 2.8x plus e to the negative 2.8x. And the square root of 1 plus y prime squared is 1/2 e to the 2.8x plus e to the negative 2.8x. Okay, let's do a little bit of simplifying. 1/2 will cancel with the 2. And let's expand out this expression, right? I'm going to FOIL this out before we do any integration. So I have pi over 5.6, and e to the 2.8x times e to the 2.8x will give me e to the 5.6x. E to the 2.8x times e to the negative 2.8x will give me e to the 0. E to the negative 2.8x times e to the positive 2.8x will give me e to the 0. And finally, e to the negative 2.8x times e to the negative 2.8x will give me e to the negative 5.6x. So now I have an integral from 0.1 to 2. I have this constant out front, pi over 5.6. And then I have e to the 5.6x plus 2 plus e to the negative 5.6x. Okay. My constant out front, you can either let it hang out or you can think of it as factoring out of the integral. Either way, it's going to stay unchanged when I integrate now. For integrating e to the 5.6x, I'm going to show you an example. We could use a u substitution here. If I let u equal 5.6x, then du dx is 5.6. So 1 over 5.6 du equals dx. So this is going to become the integral of e to the u times 1 over 5.6 du. When I integrate e to the u, I get e to the u. And then we substitute back. So I have 1 over 5.6 times e to the 5.6x. Okay, so we have 1 over 5.6 e to the 5.6x plus 2x plus 1 over negative 5.6 e to the negative 5.6x for the same reasons. Okay, going from 0.1 to 2, so then we just have to plug in and evaluate. I've got to be careful, I think that was a pi. There we go. Pi over 5.6 times all of this crazy business with 2. And then minus the same thing, except with 0.1 plugged in. And we have our answer.